Have you ever sit in a taxi? And have you ever seen that taxi drivers, when you are telling them to go by the main road and if there is too much of traffic there, they just, turn their wheel and steering wheel and they can take the inside roads, the peripheral lanes, and they can still get you out of the traffic jam. So how do they really know all this map of the city? It's like on the back of their hand, isn't it? Their spatial ability is amazingly well. So we want to know biologically, is the brain of a taxi driver any different from the brains of other normal people? So what is the biological difference here? So this study is of Maguire 2000, a very interesting study. This was to see that the London taxi driver's brain was any different from the other common people's brain. And in this study, there were around 16 right-handed males London taxi drivers, and they were all compared with the MRI scans of 50 right-handed males who did not drive taxis. So there are two experimental conditions. So there are two conditions here. One is experimental group, in where we have 15 taxi drivers, all are right-handed males, and on the other hand, in the control group, we have non-taxi drivers, which are 50 males. And in order to take part in the study, the participants had to give the knowledge test and a license that would say that, they had license for over 1.5 years minimum, and the MRI database was collected. So the sample included a range of ages, so there was no confounding variable at all. The study is correlational in nature because there was no IV as such manipulated by the researcher, and the researcher was looking if there is a relationship between the number of years of driving taxi and the anatomy of one's brain. So it was a single blind study that the researcher did not know whether she was looking at the scan of a driver or a control. It was a single blind study. The researcher did not know whether she is looking at the MRI scan of the driver or of a non-driver. So that was a single blind study to remove any research biasness. The data from the MRI was measured using two different techniques: voxel-based morphometry, that is VBM, and pixel counting. So what is voxel-based morphology? It is used to study to measure the density of gray matter in the brain, and pixel counting consists the counting of the pixel in the images provided by MRI scans in order to calculate the area of the hippocampus. So one is the gray area of your brain, and the other is the hippocampus, the area of the hippocampus that was studied in this study. Now there are two main key findings of this study. So the pixel counting here showed in an MRI that the posterior part of hippocampus was larger in taxi drivers than the non-taxi drivers, and the anterior part of hippocampus was less in the taxi drivers as compared to the non-taxi drivers. So what exactly does this mean? And the VBM showed that the volume of right posterior hippocampus correlated with the amount of time spent as a taxi driver. So the volume of right posterior hippocampus was larger, or was correlated with since how long they have been into driving the taxi. So what exactly does it mean? It means that posterior hippocampus is involved when previously learned spatial information is used, whereas the anterior hippocampal region may be more involved during the encoding of new environmental layouts. Let's do the evaluation of this study, and this clearly shows that there is definitely the difference between the brain structure of a taxi driver if you compare it with a non-taxi driver. So the evaluation of the study was a quasi-experiment. That means there is no cause and no effect in the relation. No effect, cause and effect relationship can be established. So there is no independent or dependent variable. It was naturally occurring. The brain scans were coded so that analysis could be done blindly. The researchers did not know that they were looking at the MRI scans of whom. Is it the driver or the non-driver? So it avoids any kind of researcher biasness. Since this is a correlational study, it is difficult to say what is the cause and what is the effect. Is it that because they were taxi drivers, that is why their posterior hippocampus was large? Or it could be the other way around. Because the posterior hippocampus was large, they decided to become a taxi driver. Like for example, if you have a good skill in something, if my posterior hippocampus is big, and I'm very good in understanding the spatial ability, I'm very high in spatial ability, I understand the road maps and everything very quickly, maybe I decide to become a taxi driver because I'm good at it. Then another is that it appears to have a sampling bias because all were from London, all were right-handed, all were males. So this is a kind of a biased sample that we have in the study. There are no females, there are no non-London, there are no left-handed drivers in this. That means this study cannot be generalized to a larger population but to a very specific kind of a population. And ethically sound it is because MRI is done, and it does MRI, any kind of biological test always gives a very objective result and very trustworthy, reliable result. It is not subjective at all. So MRI was done and it is not at all harmful. So it is a very good ethically used test. Subscribe to my channel to learn more lessons on IB psychology cognitive approach.